So trigonometry really is the study of triangles. I like it because I can draw a triangle. That's why I like trig. And it is pretty amazing as to what one three-sided figure, it creates a whole subject in math, which I think is pretty cool. The triangle and the circle combined together, they create all of trig. So I feel like that's pretty cool. Trig is used in aviation. It's used in navigation. It's used in a lot of engineering and like surveying. So a lot of you, I think, of hopes to going on to college to go into engineering. You're going to use a lot of trig in engineering. A lot of carpentry uses trig. So you might not think that it's applied in other places, but kind of figuring out the measure of an angle or the pitch of an angle, that all deals with trigonometry. So then that takes us to our second term that you see here. The second term is an angle. So in trig, an angle is found by rotating a ray about its endpoint. And this is where it differs from geometry. An angle has movement, and apparently I have an extra y here. So in trig, an angle actually moves. It has a rotation, whereas in geometry, it kind of is just like it's there, it's a solid kind of non-moving figure angle, but we will have a way an angle moves and it has a rotation. So we're going to draw a little picture here just so you kind of understand a couple of parts of an angle. So it says it's found by rotating a ray about its endpoint. So remember from geometry, a ray has an endpoint and it only goes in one way. Doesn't go extend in both left and right. This is called our initial side. It's where it begins. So in geometry, it's fixed. In trig, it moves. And then this angle actually rotates. And the way we show rotation in trig is to kind of draw a little arrow to give us the way it rotates, because it can rotate in two different ways. And then wherever it ends is called its terminal side. Terminal meaning end. So it has a beginning side and it has an ending side. And literally you're taking that beginning side and you're rotating it to wherever it's ending or its terminal side. This little endpoint, we know that is a vertex. So an angle has an initial side, it has a terminal side, and then it has that vertex connecting the two together. So you will see those words. You'll see that word terminal, the initial side, the terminal side. We will be drawing angles in standard position. So standard position is when our angle is on the positive x-axis and the vertex is on the origin. So every angle we draw will be drawn in standard position. And we're going to make a little sketch here. Lots of sketches kind of go along with trig. So trig it's definitely a spatial form of math. And we'll be drawing lots of pictures to go along with it. So if you like having a picture, if you learn better from pictures, trig is definitely for you because we have a diagram for everything in trig. So if an angle is drawn in standard position, the vertex is at the origin and the angle has an initial side on the positive x-axis. Maybe we'll say initial side. And then we have some type of rotation when we draw our angles. So I'm going to make my angle look like this. So this would be an angle drawn in standard position. We use a lot of Greek letters in trigonometry. Trigonometry was found by the Greeks. So we use a lot of Greek letters. This little angle notation is called theta. And you will see theta represents an angle. And you will see that angle being used pretty much in every problem. So this angle is considered a positive angle. So angles can be positive, and they actually can be negative as well. A positive angle has counterclockwise rotation. So any angle that is a positive angle is moving counterclockwise. And that's the way you would move around a coordinate grid. So usually we start here in the first quadrant. We move over to the left, and that's the second quadrant. We go down to the bottom left to the third quadrant, and then we move to the bottom right, the fourth quadrant. So generally when you're graphing or you're moving around the quadrants, the coordinate grid here, you move in the counterclockwise position. Well, in trig, besides having positive angles, we can have angles that are negative as well. And it's a negative angle not because it's a negative distance, but because of the direction that it's moving. So in geometry, you could only have a positive angle because an angle is still taking up a space. How wide is that mouth of the vertex of the angle? Well, trig, the direction that it moves forces it to be a positive versus a negative angle. So angles that are negative move in the clockwise position. We'll say clockwise rotation. So now we can have two different types of angles. We can have angles that are positive, and we can have angles that are negative. So positive angles move counterclockwise, negative angles move clockwise. It's still a distance, but the negative gives us the direction. And the little arrows we will be drawing to show the direction that the angle is moving. We have one more term, and then we're going to look at an example, and then we have a couple more terms. So like today, we really have to kind of just go through some vocab words to get an idea of what this means when we're talking about trig. Does anybody have questions so far? Stop me if you have questions. All right, so this word here that you see, the last vocab term before we do a little example, says coterminal angles. What do you think coterminal means? Or even the word co. If you have that coefficient, a co in front there.
Like with something?
Say it again, Jack.
Like with something?
With something, yeah. So usually that CO means that it has to be exactly how we said. It has to be with something. So coterminal angles are two or more. angles that begin and end in the same place. So they share the same terminal or initial and terminal sides. I'm going to use correct terminology here. So it could be two, and it could be more than two, but they are together. So if you look at the diagram that I drew on the right side, I have a diagram with a pair of coterminal angles. My angle in green begins and ends in the same place. And then underneath the one drawn in blue goes the opposite direction, but it still begins and ends in the same place. But they are two different values. So those angles have two different values. One has the positive side and the other one has the negative rotation, but they still begin and end in the same place. So we're going to see if we can find a coterminal angle. Actually, we're going to find two. What do you notice about coterminal angles if they begin and end at the same place? So look at the diagram that I have drawn here. Peter, what do you notice about these coterminal angles?
Like markings, like form a circle.
Yeah, they form
go
a
360
circle.
degrees.
Exactly. So he said they form a circle. It makes a complete circle. You have the top half and you have the bottom half. So we would find these by adding or subtracting 360 degrees. Because together they do form a full circle. So we're going to see if we can find a coterminal angle. We're also going to try and sketch an angle in degrees. So that's our first example we're looking at. So it says sketch the angle in standard position and find two coterminal angles, one positive and one negative. And the angle we're working with is 135 degrees. So draw yourself an axis coordinate grid here. You'll be drawing a lot of these. For it to be in standard position, the vertex is at the origin and it starts on the positive x-axis. This is a 135-degree angle. So a little refresher. Peter said this whole circle is 360 degrees. So Peter, if we're at the top of the circle on the positive y-axis, how many degrees would that be, Peter?
That would be 90.
Yeah.
Like if you go.
So it's almost like you're a quarter of the way around if I'm at the top of the circle on the positive y-axis, the tippy top there. Peter, if I was halfway around, we would be at?
180 degrees.
Yeah, and then 2/3, I would have, or sorry, 3/4, I would have 270 degrees. So if I went all the way around the circle, I would have 360 degrees. So pretend that there is like a little invisible kind of circle that's just taking us around here. That's really what we're kind of thinking of. There's this invisible circle. So we're going to measure an angle that is 135 degrees. And again, it's approximate. You don't need to get out your protractor and measure this. We're making an approximate guess. I know it has to be between 90 and 180. It's actually 45 degrees from 90 and 180. So that would be approximately the location of my angle. And then I have to show the direction of that angle. So my angle must have rotation. Because it's positive, it's moving counterclockwise. Every angle has to have a direction. If you don't have that, then you don't have the angle sketched correctly. So this would be my angle that is 135 degrees. So 135 degrees is my angle. So this says to find two coterminal angles. So we want one that's positive and one that's negative. And you can't use the angle they give you because that's the given angle. So how could I find one coterminal angle? Let's talk about one. Grant, how do you think we could find one coterminal angle?
Could you do 360 minus 135?
Yeah, we're actually going to start with the angle and we're going to subtract 360 from it. And that's going to give me the angle that goes underneath. So we have 135, that's our given value, and we're going to subtract 360 from it. So you're starting with your given information, you're subtracting 360. Grant, do you know what that makes?
Negative 225.
Yeah, so there's our negative angle, negative 225 degrees. So that's this guy right here. Ooh. But it wants us to find another angle. Well, I mean, look, I got two angles drawn, but I still have to find another one. And that other angle is going to be found by rotating the whole way around the circle. So you can spin and rotate and get dizzy a whole bunch of times. I could keep spinning around the circle, around and around and around. An angle doesn't stop at 360 degrees. An angle doesn't stop at 180 degrees. So to get a second angle, I would start at my initial side. I could rotate all the way around the circle. And then I can finish that rotation to go to the terminal side of the angle. So an angle can be bigger than 360 degrees. I could keep spinning around and make a cute little squiggly snail if I wanted to just continue to spin around this circle. The way I find that is by taking my original angle and adding 360 degrees, because I just spun around the circle one whole time, one whole 360 degrees. But then I still need to go back to the original, that terminal side. So I still have to end at that same place. And to end at that same place, I have to add that extra 135. And if we add those together, we get 495 degrees. So coterminal angles still begin and end in the same place. And if you look at my diagram, I try to be as neat as possible and use different colors. But you can see I now have three angles. The original angle that was given, the negative angle underneath, and then my angle in blue goes all the way around and then it extends that extra spot to go back to the terminal side. Does anybody have questions on that? So we have two more terms down below that we're going to talk about today. And the first one is the measure of an angle. So it kind of correlates with exactly what we're given above. The measure of an angle is the amount of rotation. So remember, our angles have movement. They rotate counterclockwise or they rotate clockwise. So the amount of rotation from the initial side to the terminal side is how we measure an angle. We measure an angle in something called a degree, which is what you guys all know. And we measure an angle in something else called a radian. And that's the new part that we will be talking about in trigonometry. In trig, angles are measured in radian form. The radian actually was found before the degree measure. So the degree measure was actually way after radians were created. So think about if you measure a mile or you measure distance. We measure a mile, we can measure it in kilometers. And it's the same thing with trig and angles. So you can measure an angle in degrees and we can measure it in radians. I can measure distance in meters, I can measure it in feet. So it's the same kind of system. They mean the same thing. They're equivalent to each other. There is a formula that we'll see as to how I can kind of find one, use a degree to calculate a radian. So a radian, 1 radian by definition. This is a little weird. So it's a measurement of a central angle. And I'm going to draw a picture too. And that angle we call theta. So that is the angle that we will be using. That intercepts an arc, and we call that arc S. That arc is equal in length to the radius. And the radius is R. So we have a central angle, we have this arc, and we have a radius. And I know it seems like a whole bunch of mumbo jumbo right now. So draw yourself a little circle. And inside that circle, we're going to make an axis. And we'll do this a lot. So there's my angle. A central angle from geometry is the angle that's connected to the center of the circle. That's called a central angle. So right here is my central angle. The vertex is in the center of the circle. So 1 radian is found when my arc, which is the edge of the circle, and the radius, which is from the distance from the center of the circle to the edge, is the same value. So when the arc and the radius are the same, I have this 1 radian unit. The measurement of an angle bigger than 1 radian is found by taking the ratio of the arc divided by the radius. So that's how I find a measure of an angle. By taking the distance of the arc divided by the distance of the radius. And you can actually see that at the bottom of my screen, it's there again. One rotation about the circle, which we actually call a revolution, So a rotation or a revolution. If I go all the way around the circle, does anybody remember the formula for the circumference of a circle? So think back to geometry. What's the circumference of a circle? How would I find that? The outside of the circle. What's that distance? How could I find that?
Is it pi r squared?
That's area. So you're so close. Jenny?
Is it 4/3 pi r cubed?
Oh, wow. You're giving me like volume.
Oh,
Hey, you're going above and beyond. I just want that outer edge. How about 2 pi r? So if I want to go around the circle 1 full time, 1 rotation, 1 revolution, that distance is 2 pi r. That's actually s. That's the arc length. So instead of saying circumference, we're saying circumference is the length of the arc. So our circle now has an arc. So if my angle is all the way around the whole circle, the way I find the measurement of that angle is by taking the arc length, which is 2 pi r, because it's all the way around the circle, divided by the radius. Well, I'm going to divide that by r. So it's really s divided by r. 1 rotation or 1 spin around the circle, my r's cancel, is a distance of 2 pi. So Peter told us above that if you go all the way around the circle, it's 360 degrees. In radian form, all the way around the circle is 2 pi. So those are 2 equivalent angles, one in radian measure and one in degree measure. So one rotation or one revolution around the circle is a distance of 2 pi. So we're going to see if we can try and use that to find out a couple other values. So the radian is the same thing as like your centimeter to your inches. So it's that same kind of measurement where I can measure something in 2 different ways, 2 different types of units. So the radian measure of an angle is found by taking the angle and dividing the arc length by the radius. And it says here that theta is unitless. So the actual notation for an angle is unitless. It's just a real number. It's like x. So think of it as kind of being x. In this example, we want to find the radian measure of 1/2 of a revolution. So think of that as being a rotation. We call it a revolution around the circle. We're spinning halfway around the circle. So my angle is 1/2 of a revolution. That's my angle. The way I would find that, I'm finding the radian measure, is by using the formula S over R. All the way around the circle is 2 pi R. But I'm only going halfway around the circle. So I have to take half of the distance 2 pi R. So if I was going all the way around, it's 360. Half is 180. So we're doing the same thing here. And then I have to divide that by the radius because that's how I find the measurement of an angle. So I have to take the distance of the arc divided by the distance of the radius. Well, I don't know the radius, but I know I have to divide by R. So 1/2 a revolution around the circle is equal to what if I simplify this little algebraic expression? Joe, what would you get if you simplify this algebraic expression?
You would have pi r divided by r.
Yeah.
Just simplify to pi.
Just simplifies to pi. So if I'm going around 1/2 of the circle, my radian value for that is pi. So now I have a measurement in radians instead of a measurement in degrees. We know that is also 180 degrees. So if I do the same thing, if I want to find a quarter of a revolution, so 1/4 of the way around, I would say, all right, well, I know the whole distance is 2 pi r. That's the distance of the edge of the circle, the circumference of the circle, the arc. That's called our arc. I only want 1/4 of that. And then based off of the measurement of an angle, I have to take that arc and divide it by its radius. So now I really have 1/2 pi divided by r, or I have 1/2 pi, which rewrite as pi over 2. So pi over 2 represents the angle if I'm going 1/4 of the way around the circle. And if you look below, here are 6 common angles in radian measure. And I could continue to find these common angles by going 1/8 of the way around or 1/6 of the way around. So we could calculate all of these by saying, how far around the circle do you want to go? And then taking that distance and using our angle measurement. So a 30-degree angle is really pi over 6 in radians. Questions? All right, so we're going to see if we can try and use this to graph an actual radian value. And my goal is to get you to think about a pie being a physical pie that somebody put in the oven and made for you. So your favorite pie, right now it seems to be pumpkin. That's the fall, winter pie. But think of the pie as like an apple pie, a pumpkin pie, a lemon meringue pie. We're going to talk about eating pie. So it says sketch each angle in standard position and find the coterminal angle. So the first thing we're going to do is we're going to draw a circle. And in that circle, I want you to draw an X, Y axis. The reason we have to draw that is because every angle starts at the origin and the initial side is on the positive x-axis. So in standard position, I need to have an angle drawn in a specific way. All right, so my angle is 13 pi over 6. Remember, that angle would have been found by using 2 pi r and saying, I want to go how far around the circle. We are going to take this circle and divide it up into pieces of the pie. That's why I said I want you to think about having a physical pie in front of you because it's round. So a 9-inch pie is sitting in front of you. The denominator would be how many pieces you're going to divide half of the pie into. So my denominator is 6. So I have to divide the top half into 6 pieces and the bottom half into 6 pieces. And I know you're saying, why do I just do half? Well, because really we have to double it. This number was a simplified form because the initial amount is 2 pi r. So try your best. Those sides didn't go very well. Here we go. That looks better. So this is a simplified form. So now you have to count pieces of the pie. The top value is how many pieces you are going to eat. So if I start with my positive rotation going counterclockwise, I'm going to count each piece of pie until I get to my 13th piece of pie. So a quarter of the way around is 3 pieces, halfway is 6, 3/4 is 9, all the way around I have eaten 12 pieces of pie. But this one says we need 13 pieces. So we have to keep going around till you get to that 13th piece. That 13th piece is called your terminal side of the angle. So this angle is bigger than 360 degrees, or it's bigger than pi. Questions on how I drew that angle? Okay, so the next part says find a coterminal angle for each. Remember, a coterminal angle is an angle that begins and ends in the same location. If you look at my diagram, I need another angle that still begins and ends in the same location. So my angle could begin, let's go with purple, and end in the same location, but have the opposite rotation. And if you count the pieces of the pie, since you have it drawn, that would be your coterminal angle. So if I count here, I'm underneath my angle because I'm going in the negative direction. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of the pie. So a coterminal angle would be negative 11 pi over 6. So it starts in the same place, it ends in the same place, but it goes in the opposite direction. That's why it's negative. Questions? I'm going to draw one more angle for us. Let's look at the next one. So we have 3 pi over 4. The denominator tells us how many pieces of the pie to place in half of your pie. So I have to have 4 pieces on the top and 4 pieces on the bottom. Starting in the center and the initial side, I'm moving to 3. 1, 2, 3. Make sure you draw your end side as well. So it should be obvious where it starts and ends. You need your initial and your terminal side. And then the co-terminal angle would be the one going in the opposite direction. And you can just count 1, 2, 3, 4, 5. It's negative because we're moving in the opposite direction. So your homework tonight will practice sketching angles. Draw those pieces of the pie, placing your slices based off of the denominator. So how many slices of pie are you eating? And that number in the denominator would be the top slices and the bottom slices. And think about when you slice a pie, like you cut it in half first, and then you kind of slice the top half and the bottom half. Same thing when you're graphing a radian value. So have a great day. Please fill out that homework form if you have any questions. And then we're going to continue tomorrow and Thursday. So 3-day section. Have a fantastic day.
Thank you. Have
Okay.
a good day.
Have a
See
good
ya.
day.
Have a good day.